Distributed VR architecture. So what is distributed? Distributed means that processing and data are spread out over multiple computers, usually over a network. And basically, this distributed VR architecture can be divided into either a single user system and a multi-user system. There are two types of this distributed VR architecture, single user and multi-user. For single user system category, there are two examples which are multiple side-by-side display and also multiple LAN network computers. While in multi-user system, here are the example of this category, which is client-server system, peer-to-peer system, and hybrid system. Here are the example of the single user and multiple display. As you can see from this figure, there are several display, 1, 2, 3, 4, 5. There are 5 display and only one user that can control the system. So we can call this category as a single user and multiple display. Side-by-side display. For this category, basically is used in the virtual reality workstation like desktop base or in a large volume display like in cave or the wall type of display. And if we want to implement this side-by-side display, it is suggested to use one PC with the graphic accelerator for every projector so that it can support this kind of display. As you can see from this figure, there is a large screen video channel that is created by using multiple video channels that adjacent to each other. There is one problem that happens when we use multiple display, and this problem is called as the non-synchronized display. It means that the screen is not synchronized correctly, that make the image is misaligned. You can see this problem from this figure below here. If you look carefully, you can see the channel that is not aligned well. Okay, it's here one place and also here one place. It's not aligned well, right? So it's like when you do your assignment 1 panorama view, you need to stitch the photo well. If not, you will see this kind of the problem. Okay, non-synchronized display. But this one is happen on the screen. Okay, the screen that use multiple display and then is display this misaligned photo into this screen. And basically this problem will cause and affect the VR realism, and it will increase the delay time, which is the latency, and it will cause the simulation sickness. A user will feel dizzy if they are in the VR environment that is not aligned well. In order to solve this non-synchronized display, they have proposed several solutions to solve this. The first solution is using software synchronize. In this solution, the system will commence that frame processing start at the same time on different rendering pipe. If you look at this figure down here, we have two channel, and how we want to make sure that these two channel or these two pipe will project image at the same time. So for this first solution, that frame processing will start at the same time on different rendering pipe. Okay, it will start this frame processing start at the same time on different rendering type. So it start over here, but this solution is not working. Why? Because it cannot solve the problem, because if one pipe is overloaded, one image will finish first. Okay, so this first solution using software synchronize is not working. Okay, it's not working. So they come out with the second solution in the next slide. Let's see whether the second solution can solve this problem or not. The second solution is using frame buffer synchronize. In this solution, the system will commence that frame buffer swapping start at the same time on different rendering pipe. Okay, it's the same pipe or the same channel. We have two channels. How we want to make sure that these two channels will project the image at the same time. So for this frame buffer synchronize, it will command that frame buffer swapping. Okay, it will start here. Okay, the swapping will start at the buffer. So the synchronization command is start here. So by using this frame buffer synchronize is also not working. Okay, it's not working, cannot solve this problem because the swapping depends on the electronic gun refresh, and one buffer only will swap up to once per 72 seconds before the other. So it cannot project the image at the same time as well. So this frame buffer synchronize cannot solve this problem. So they come up with the third solution in the next slide. Let's see whether the third solution can solve the problem or not. The third solution is using video synchronize. In these solutions, system will comment that the CRT is the cathode ray tube vertical beam start at the same time. One cathode ray tube become the master. Okay, one is become the master, and then one become the slave CRT. Okay, one is master CRT, one is slave CRT. So this command will start over here at this cathode ray tube. Okay, it will start over here. But this solution also is not working because if there is a horizontal beam, is also not synchronized as well. One line may be too many or too few. So this solution of video synchronize also cannot solve this non-synchronization display. So what is the best solution to solve this? Let's find out in our next slide. So at last, the best method to solve this non-synchronized problem is that by having or combine the software synchronize, combine with the buffer synchronize, and also combine the video synchronization of the two or more rendering pipe together. So it will have the synchronization command over here on different pipe, and also it will have the synchronization command in the buffer swapping in here, and also it will have the synchronization command on this cathode ray tube as well. So by combining these three methods, okay, combining the software, buffer, and video synchronization together, we can solve these non-synchronization problems. As an example of this ship simulator that show multiple display that show all the screen are synchronized perfectly. Okay, as you can see from this figure, is synced and synchronized very well here, even though it's used more than 8 of the window video channels, but it's all are synchronized precisely.